Hey, in this video I will show you how to make your first Unity game in a few hours. We will make a dungeon crawler game with simple gameplay and minimalistic pixel art graphics so everyone could draw it. Note that this tutorial is not about optimization, beautiful code architecture, cool graphics or complicated features. We will just make a full simple game the fastest way we can. We will make one complete level with several rooms. There will be pressure plates that open doors, destructible and movable pods, enemies with simple AI, victory and defeat conditions, and our character that can move with keyboard and cast spells with a mouse. In the end of the video I will show you what other features you could add after that, but for now let's focus on basics. By the way, you can try WebGL version of the game in your browser, link in the description. There is also a link to Unity project if you need it. Okay, let's start. First we need to create Unity project. I will name it niceplay dungeon and will use Unity version 2018.3, but it's not that important for such simple game. Since we are making 2D game, we will change template to 2D. Then I'm going to change my editor layout, so it was handy for me to work in it. I will need both scene and game views, so I can change something on the scene and at the same time see what camera shows to player. Of course, you can use your own or default layout, but it will be easier for you to work in the same appearance as I do. Then we rename our scene to level 1 and we open it by double-clicking it. Then we create new folder and name it textures. We will put our textures and sprites there. It's a good idea to make some kind of mockup like this before making a game. It gives vision of how graphics would look, so you don't have to change every sprite on the go later. To make our graphics, we will need to draw several simple sprites. You don't have to be a talented artist to be able to do it, but if you don't want to draw even such simple sprites for some reason, you can download mine, link in the description. I will be using Affinity Photo to draw, but you can use any other graphical editor which supports transparency and PNG format. Any Photoshop-like program will do, you can even use some free online editor. First we will draw a player character. We will need 11 to 11 pixels image. We will leave some empty space on the bottom, so sprite center was where the wizard body center is. It will remove additional problems with coordinates in the future. Save picture as PNG and our texture is ready. Then we draw pod. It will be 5 to 5 pixels. We will need to draw 3 different sprites for 3 stages. Full health, damage lightly, damage severe. In damage lightly we will add some cracks, and in damage severe we will expand these cracks. Then skeleton sprites 5 to 5 pixels. Same as with pod, we will need 3 sprites for 3 stages, full health and 2 sprites with cracks. Another 5 to 5 pixel sprite for gold cup, which must be picked up to win the game. And the most important texture, 1 to 1 white pixel. It will be used for every rectangle and square object in the game. Walls, doors, pressure plates, spells and any other. Okay, all textures are ready, now we need to set up input settings for them. Drag one of the sprites, for example player, on the scene, so we see how it looks. Then select all our sprites and textures folder and start changing settings. First we will set pixels per unit from 100 to 1, so 1 pixel equals 1 world position unit. When we apply changes, all our sprites will become bigger on the scene. As you can see, our sprite is very blurry. It's because we need to change filter mode from bilinear to point, the only right mode for pixel art graphics. Also, we want to change compression to none, so our sprites don't corrupt. Okay, input settings are set. Now let's change camera settings. I will rename main camera to camera, because it's the only one on the scene. Then we will change size parameter to 60 and change background color to gray. It will be our floor in the dungeon. Okay, now we will add box collider 2D to our wizard. Generated collider is too big because it's the same size as the sprite, so we will have to resize generated collider by changing it manually with a mouse or setting coordinates in the inspector for more accurate results. Then we add rigid body 2D component because we want our wizard to move and be affected by forces. Then we are going to create walls from our pixel sprite. Drag pixel on the scene and rename it to wall. Let's scale our wall so it becomes larger. Now change color to dark gray, so it's different from floor color. We will need more than one wall, so let's create prefab from it. Let's create new folder objects and drag wall and player into it. Now duplicate wall and insert a few more for testing. Since we created prefab for a wall, now we can change one wall, apply changes, and then all walls will change. Let's add box collider to one of the walls, apply changes, and now all our walls will have collider. Nice! Let's hit play and see what will happen. As you can see, our wizard just fall down because we didn't disable gravity. We are not making a platformer, so we will change gravity scale to 0. Don't forget to apply changes so prefab is always up to date. Okay, cool! Now our wizard doesn't fall. Let's move him by dragging manually with the mouse on the scene view. As you can see, colliders work but very slowly. It's because we use default physics settings. Also, our rigid body needs some fixes. If we copy our wizard and collide them with each other, we can see that they are rotating freely. We don't want our objects to rotate, so we have to check freeze rotation for Z in our rigid body and apply changes. Now our wizard won't rotate no matter what. Now let's make some world physics adjustments. Let's reset our gravity scale on player from 0 back to 1 because we will remove gravity at all. We open project settings and select physics 2D tab. Here we change our gravity to 0 so nothing falls down. We also want our physics calculations to happen more often per second, so our collisions are more accurate and fast. For that we will need to lower fixed timestamp. For example, 4 times less. Note that this can cause some performance issues, so you may want to set up physics and time settings more accurate later. Okay, now let's work on sprite layers. As you can see, walls are overlapping our wizard now, and we can't see his head. We want to see head before walls, so we need to create some sorting layers for it. We will create all layers at once, so we don't have to return here later. The lower the layer is, the closer it to camera. Now, when all sorting layers are created, we can set it in sprite renderer for player and walls. Now our wizard sprite is before walls and we can see his head near a wall. Nice! Now it's time to add controls, so we can move our wizard with the keyboard. For that we will need to create new script. Let's create new folder for scripts and create C# script. We will name it player. Drag this script to our player object and double click it to open. I am using Rider for coding, but you can use any other program if you want, for example Visual Studio. It has free community version. All physical interactions are better to handle in fixed update method. It is called certain times per second and works correctly with other physics on the scene. Let's add boolean variable alive so we know if player is alive or not. We can control character only when player is alive. Now we need to know which direction player is moving each update. It depends on which keys are currently pressed. D and A keys control X-axis, W and S keys control Y-axis. First we check which keys are currently pressed to get movement direction, and only then we move our character. Let's add constant for player speed. If we want our character to move with the same speed in all directions, even diagonally, then we need to normalize our direction vector so it is never more than 1. After that we multiply it by speed and we have our movement vector. Now we only need to set current rigid body velocity to our movement vector, and don't forget to set alive variable to true so we can control our character. I also should mention that getComponent method is not meant to be called very often, so in future you may want to store some important components in variables for better performance. But as I mentioned before, this tutorial is not about optimization and I tried to make it simple, so this will do for now. Okay, let's try our keyboard controls. Cool, now we can move our character with WASD keys. But as you can see, our camera doesn't move with our character. Let's fix this. We just need to drag camera to our player object, apply changes, and that's it. Now camera will follow player. Well, let's set some other objects on the scene. I will start with pods. Drag our pod sprite on the scene, rename it, add box collider and rigid body so we can move it around. Hit play and see how it works. Okay, we can move it, but not the way we want. Let's create prefab for our pod and add more of them on the scene for testing. As you can see, our pods are rotating and floating like in space. Let's fix this. First we want to disable rotating by checking freeze rotation Z. Good, now pods at least don't rotate. But they are almost unstoppable now. If we push it, it will never stop. To fix that, we need to add some linear drag. I'll make it 100. That's much better, but pods seem too light now. Let's add some mass to them. Our player have mass 1, let's make mass of pot 5. Nice, now we can see that pots are really heavy and we need some time to move them. Looks way more realistic. Okay, good, we have some objects now and can move on. Let's make our first room. Duplicate some walls and arrange pots in the room randomly. Leave some narrow passage, we will add door there later. But before that, let's make pressure plate. That will trigger door opening when it's pressed. Pressure plate will consist of 2 rectangles, so we just use our pixel sprite here, just like with walls. Let's resize it to needed scale and change color. This part represents size of plate, so it should be darker. Let's add box collider, but we don't want our rigid bodies to collide with it, so we mark it as trigger. Now all objects can move through this collider, but we can still see when something enters or leaves trigger zone through script. That's exactly what we need. Now let's make surface for our pressure plate. Just copy our object and paste the new one inside the old one. Rename it to surface. We will need it later in the script. Surface must have different color, let's make it a little lighter than the floor. We also need to move surface higher, so we can see that it's a button and it can be pressed. We don't need collider on surface, so we just remove it. Now we need to create script for our pressure plate and attach it to our object. Let's name it move door on trigger. Also, let's create prefab for our pressure plate. Let's start small with our script. First, let's make animation of pressing. Let's create boolean variable pressure plate pressed. Then I will show you how trigger collider methods work. We add 2 standard methods, on trigger enter 2D and on trigger exit 2D. These methods are called every time any rigid body 2D enters or leaves our trigger collider. Let's add log message on these events to see if it works. As you can see, we forgot to set certain layers for our pressure plates and they bugged, so let's fix it now. We need to change certain layer for both our rectangles to pressure plate, but it's not enough because we need surface to be in front. So let's set order in layer from 0 to 1. Now surface rectangle will always be in front of parent rectangle. Good. Now let's test our script. As we expected, we get messages in console every time we enter or leave pressure plate. Now let's add animation. Return to our script and make some adjustments. Let's change our variable pressure plate pressed every time we enter or leave zone. Also, we can remove debug log messages, we don't need them anymore. Now create method set pressure plate state. If new state is different from current one, we change state and set surface position depending on new state. If it's pressed, we set local position for surface child to 0, 0, 0. If it's not pressed, set Y position to some small number like 500. It should be the same as we set in the prefab. Now, instead of just setting variables, let's call our new method in our trigger enter and trigger exit events. Hit play and yay! We have animated pressure plate now. We can also press it with other rigid bodies like pots. As you can see, we have some bug if we have more than one object on the pressure plate. It's because we change state to unpressed every time any object leaves trigger zone. It will be correct for one object, but not for several objects. Let's fix this. Let's check state of our pressure plate every fixed update. We need to see if it touches any object. We can use isTouchingLayers function to do it. If it touches something, we set pressed to true. If it doesn't touch anything, set to false. Since we already check it every update, we can remove all trigger enter and exit events. Let's test our fix. Yes, now our pressure plate works correctly no matter how many objects we place in it. Good, but our pressure plate doesn't do anything yet. Let's add door so we can move it by triggering pressure plate. Door is just a rectangle, so we use our sprite pixel again. Resize it the way we want and change color to black. Same as with walls, we need to add box collider. Create prefab for door as for any other objects. Then we return to our pressure plate script. Since we want to move door through our script, let's add public transform variable, so we can link our door object later in the editor. We will start from small, let's just move our door from script every fixed update. We just need to change position of door transform. We will use vector2 move towards method for it. Just move to the left from current position, but not more than 15 multiplied by fixed delta time. Fixed delta time stands for time that has passed since the last fixed update call. If you want something to move or increment smoothly in update or fixed update methods, you should use delta time or fixed delta time as multipliers respectively. Let's return to editor. If we did everything right, we will have new parameter in pressure plate inspector, affected object. Let's drag our door from scene to this parameter. Good, our pressure plate is linked to this door by script. It should move our door now when we hit play. Yes, everything works fine, door is moving, but all the time, because we didn't set additional conditions. Let's fix this. We just need to add one simple condition. If pressure plate is pressed, move the door. And yes, now door will move only when pressure plate is pressed. To make game more challenging, we need the door to close if pressure plate is not pressed. Let's do this by improving our script. Create public boolean variable named return door on release. Then, if pressure plate pressed is false, we check if we should return this door on release or move it in the opposite direction with the same speed. We can set our new variable to true through the inspector, and yes, when we do it, we can see that our door moves to the right when pressure plate is not pressed. As you can see, our door doesn't have any limits and continue moving when it shouldn't. Let's fix this. We need to create public end position and speed so we can change it through inspector in editor. Also, we need to store our start position in private variable. We will remember start position when our script starts, so we don't have to enter it manually. Now let's change code that moves door. Now door will move towards end position while pressure plate pressed, and towards start position if pressure plate is not pressed. We also change 15 to speed variable, so we can change speed from editor for each pressure plate. Now we need to set end position in editor inspector. I want our end position to be here. Let's remember these coordinates and copy them. Now paste these coordinates in pressure plate end position parameter. We also need to enter speed value. Let's make it 15. We finished with script values. Now we need to return our door back. It will be its start position. Let's hit play and see how our door works now. Yes, now it stops when it reaches end position at start position. Our pressure plate works perfectly. We can press it with our character or use pods so plate is pressed forever, if we need to return to this room later. Now when we have player character, walls, pods and pressure plates which open doors, let's make a little bit of level design. Add more rooms, plan level layout, think where the level will start and end. Add some more doors and pressure plates and arrange some pods randomly so rooms doesn't look too boring. I decided to make other pressure plates more interesting. First one was simple. We could just stay on it for a second and then run through. Next pressure plates will need player to think a little bit and use pods somehow. Don't forget to change affected object and end position values for new pressure plates or nothing will work. Same as with previous doors, find best end position and start position and link door to pressure plate script. I want my second pressure plate to close door when it's pressed, because there will be pod on it. In the third room, player don't have enough time to run from pressure plate to door, so he will have to use pod. But since player already saw a pod on pressure plate in the second room, he should know that pods can be used that way. It's a good example of tutorial without any text. We teach player game mechanics by letting him complete easy tasks one by one. Okay, we designed 3 rooms, let's test it. Actually, testing takes a lot of time during the development, especially when the gameplay is simple and interesting. First room is easy, just press the pressure plate, that's it. On the second room, we need to move pod from the pressure plate so the door opens. Pressing the plate will close the door again. In the third room, we can't reach the door fast enough, but if we move pod on the pressure plate, door will stay open forever. And the rest of the level is not ready yet. Let's add some more pods on the level and then add a few more features. Well, now let's add spells in the game, so player can damage objects and enemies. Spell should be square 2 per 2 pixels, so we will just use our pixel sprite and scale it. Let's change color of the spell to light purple. Now we need to add box collider and rigid body, because our spell will move all the time. Let's turn on isTrigger property on collider component, because we don't want our spells to collide with anything, we just need to catch on trigger enter events. As always, add spell prefab and make script for it. I will name it Projectile. Add script to our spell, open it and do some programming. Let's add 2 public variables, speed and angle. Angle will be stored in radians, not in degrees. It's for easier calculations. Now we calculate vector of our velocity by using cosine and sine of angle and multiplying it by speed. Then we can set rigid body velocity or change position manually. It doesn't matter here. I will change position manually. When you do so, don't forget about fixed delta time multiplier for smooth movement. My Unity plugin here isn't happy that I call transform too often. I didn't want to focus on optimization in this tutorial, but let's make it at least once. Instead of calling transform every fixed update, I create local variable and set it in the start. Now we can access our transform much faster through our variable. Okay, let's see how our spell fly on the scene. Let's change speed and angle values on the go. As you can see, everything works fine except a few things. First, our spell must be in front of other items, but it's on the back. It's because I didn't set sorting layer. Let's fix this. Good, now our spell will be in front of other objects, but now we need to fix one more thing. Spell press our pressure plate, but it shouldn't. It's because it have rigid body and our pressure plate is pressed when any rigid body touches it. We can fix it in several different ways. I will just add new sorting layer. It is used for physical interactions. Now I change layer for spell from default to this new layer. Then we go in script for pressure plates and change parameter in our condition is touching layers. Previously we checked if we touch any layer, and now we will check if we touch default layer. So now pressure plate will react on anything except projectiles. As you can see, everything works fine now. Our spell doesn't press pressure plate, but player and pods can still do it. We need our spell to damage destructible items. Let's do it. We are going to check events where something enters spell trigger collider. Since we have different types of objects, let's set some tags so we can easily distinguish them from each other in the script. Let's create player wizard tag, monster tag for skeletons, item tag for pods and wall tag for walls and doors. Now set right tag for our existing objects. We don't have any monsters yet, so we will assign tag for monsters later. Now let's return to our projectile script. We need to check tag of other collider every time it enters spell trigger zone. If our spell collides with anything, it must be destroyed. Also, if spell collides with item, for example pod, item must be destroyed as well. We will just hide it for better performance. Let's return to editor and test. Yes, spells now destroy pods and disappear after collision, great! For now it's enough. But I'm tired of moving spells manually on Scene tab. So let's add player ability to cast spells with the mouse. Open player script. Let's add mouse controls in update method. First we check if our player is alive. Then let's catch moment when our mouse left button is pressed. Every time mouse button is pressed, we will create spell. To do that, we will use method instantiate. To instantiate object, we need source. It will be our spell prefab. But to use it, we need to create special folder resources and drag our prefab into it. Now we can use resources load method when we instantiate object. As you can see, we created spell object on scene, but it appeared in the wrong place. That's because we didn't set any additional properties after instantiating. Let's do it now. First we need to set spell position to current position of player. Then we need to set speed of our projectile, let it be 100. And the last one, we need our spell to fly towards mouse cursor, so player could aim. To get the right direction, we need to calculate angle between center of the screen and mouse cursor. We will use math_arctangent2 function to do it. We just need to enter difference between y coordinates and x coordinates, and that's it. We get angle between 2 points. Now let's test spell casting in the editor. Yes, now wizard casts spells every time I press left mouse button, and I can aim with the mouse, cool! And our spells work correctly, they destroy pods and disappear on collisions. We don't need spell on this scene anymore, let's remove it. Now let's improve our spell casting system a bit. I want wizard to cast spells repeatedly while I hold mouse button, so I don't have to click it all the time. To do that, we need to add spell cooldown. We will make it pretty small, so we can cast 5 spells per second. If spell is on cooldown, we need to reduce remaining time. Now we cast spell only when it's not on cooldown, when spell cooldown variable is 0 or less. Let's change our condition a bit as well. Instead of casting once per click, we will cast it while button is pressed. The only limit is cooldown. Don't forget to set cooldown on the cast. Let's test our new spell casting system in editor. Good, now wizard casts spells in automatic mode, which makes controls more pleasant and balanced. We don't have to click mouse button all the time anymore, we can just hold it, nice. As you can see, I accidentally moved a wall during editing, so let's return it back on its place. Good, we implemented simple projectile system, but let's make it a bit more interesting. I want our pods to have more than one hit point, let's make it 3. For that we will need to make new script, I will rename it to destructible item. Attach our new script to pod object, apply changes and open script. We need 2 public variables which we will set through editor inspector. Max health for hit points and array of sprites, so we can change appearance of our pod depending on current health. We also need private variable health, which will stand for current hit points. Health should be equal to max health in the beginning, so let's assign it automatically in start method. Now we need to create new method called damage, which will decrease health. It will check if item is destroyed and hide it if so. If item is not destroyed, we need to change appearance of it by changing sprite to damaged one. We will have 3 health and 3 sprites for it. Full health for 3 HP, damaged lightly for 2 HP and damaged severe for 1 HP. On 0 HP item will be destroyed, so no sprite is required. To assign an array of sprites, we just need to enter size of our array and then drag needed sprites into element fields in the inspector. Now let's fix our projectile script a bit. Instead of instantly disabling item, we will now get component destructible item, which is our new script, and then call damage method with parameter 1, since we want to damage it by 1 hit point. Let's return to editor and test our improvements. Now when we hit pod, it doesn't instantly disappear. Cracks appear on it, so we can now see which pod is already damaged and how much health left. Now when we know how to make destructible items, let's add enemies. Drag skeleton sprite on the scene, set certain layers to monsters, add box collider and rigid body component. Freeze rotation by Z and create new script named monster. Attach script to our skeleton and add skeleton prefab. Now let's work on our script. Since monsters are also destructible as pods, let's copy some code from destructible item script. Max health, health, sprites array and method damage. Now return to editor and enter values in our monster script. Max health will be 3 as well, so we will have 3 sprites. We can drag sprites into inspector as we already did before for pod, or click the small button near field and pick needed sprite from a list. Apply changes as always and hit play to test skeleton. Nothing happens, that's because we forgot to change projectile script. Let's fix this. If spell collides with monster, we will now call damage method, same as with pods, but instead of destructible item component, we will use monster component. Also, don't forget to set tag on our skeleton to monster. Let's create a few more skeletons for testing. Okay, now our skeletons destroys instantly on contact with the spell. It happens because we forgot to set health to max health on start. Let's fix this quickly and then everything should be fine. Good, now our enemies are destructible too and they also have 3 hit points. Now let's add some simple AI. I want skeletons to constantly move towards the player. Let's make adjustments to our monster script. We create new constant named speed, which is a little bit less than player speed. Now we calculate angle between monster and player every fixed update, so monster knew in which direction it should go. To get player position, we find game object named player on scene. To find angle between 2 points, we use attend2 method from math library, same as we did with spell aiming. Now we just need to get the right vector by using cosine and sine functions and then multiplying it by speed constant. As you can see, everything works just fine. Skeleton is now moving towards the player, but they move too straight forward. Let's add some randomness in their movement. Add a few skeletons and slow down a bit their speed for easier debugging. Now add some random number in radians where we calculate angle. And voila! Now skeletons move a little bit randomly. I think it looks better. Now we need to think when skeletons see player and start to chase him. As you can see, currently skeletons try to chase player on any distance, even if they can't reach him. We could add pathfinding to them and other advanced AI features, but let's try to keep it simple. Before I start to make adjustments to AI, let's change one thing. I don't like that we use find on scene too often to get player position, so let's remember player object as static variable in player script, so we could use it anytime from any other class. Just assign player object to this on start, and now we can get access to our player object in any other scripts. Okay, now let's return to our monster AI. I want to keep it simple, so let's just add some distance on which our monster start to see player. To calculate distance between 2 points, we can use vector2distance method. If distance equal to 80 or less, then player is near and monster should move towards him. If player is far, then our monster will walk around, facing new random direction every update. As you can see, our adjustments work. Skeletons near player move towards him, and other ones just walk around until we come closer. Nice! Now let's return speed constant to 30, so our skeletons went too slow. A little bit of level design, let's add skeletons to some of our rooms. Not so many at first, so player could learn how to fight them, and more in the last room for some challenge. Our level is almost ready now, by the way. Main features are already done. Let's test our level. Everything is according to plan for now. Pressure plates and pots work fine, skeletons walk towards player, spells damage destructible items and enemies. But what happens if skeleton reaches the player? Well, for now nothing happens, just a little bit of petting and that's it. Well, let's fix this. Return to monster script and add onCollision2D method. It will trigger every time skeleton touches any other collider. Our player object has tag player wizard, so let's compare tag, and if it's player wizard, we need to restart our scene. We will use scene manager load scene for it. So now when skeleton touches the player, game scene will instantly restart. Let's add one skeleton in the first room for testing and hit play. Yes, now when skeleton touches the player, game restarts, nice. We're almost done, but we still didn't make a few things. We need to make victory conditions and victory and defeat animations, so it doesn't look like something bugged and game just restarted by itself. For victory, I decided to add gold cup, which will be in the end of a level. Drag gold cup sprite on the scene, add box collider and mark it as trigger. Create prefab as always, create new script with name gold cup and attach it to our object. Open script and create onTriggerEnterToD method. Now we compare tag of collider, and if it's a player wizard, then we will trigger victory. By the way, compare tag method is more efficient than just comparing strings, so I decided to fix it in my projectile class. Now let's return to our gold cup script. If player enters gold cup zone, player picks up it, so let's disable it. Let's test if our script works and proceed. Yes, gold cup disappeared, good. Now we need to add text on scene. I will use 3D text because it's very easy to use. Let's change anchor to middle center and alignment to center. Set font size to 64 so the text is big enough. Since our camera has same height in all aspect ratios, we can move up our text near the top screen side and it will be always visible. Let's change text to victory. As you can see, walls and other objects on scene overlap our text. It's because we need to set sorting layer for our text. But there's no such setting in text mesh component, so we need to add additional component for sorting. It's called sorting group. After we add this component, we can set sorting layer and order in layer like we could with sprites. Set sorting layer to GUI. Now let's make our font bold and change color from white to yellow, same as our gold cup. I don't want to create special game object for GUI, so let's just attach our text to player object as a child. Change name of it to victory text. Now duplicate it and we can make another text for defeat. Let's hide victory text so that it doesn't interfere. Rename copy to defeat text, change color to red and text to defeat. Now disable all texts, they will be hidden until we show them through script. Let's return to player script. We need to add two new public methods, victory and defeat. They will show our texts and restart our scene after a little delay. Find child named victory text or defeat text and use setActiveTrue to unhide text. Now create new method, restart level with delay, with IEnumerator type and one parameter, delay. In this method we first write yield return new wait for seconds, so game waits before doing next action. And then we call load scene method that we already used for defeat. Now we need to use our enumerator. For that we need to use a method called startCoreRoutine, in which we use our last method as a parameter. Let's set victory delay to 3 seconds and defeat delay to 2 seconds. We also need to remove player wizard from world after defeat, but we can't just disable game object because camera and scripts will stop working then. Let's first set alive flag to false so we couldn't control him after death, then disable sprite renderer component so our wizard sprite isn't visible, disable collider and disable rigid body simulation so wizard collider stops physical interactions. Now we need to change monster script. Now on collision we will not just restart level, we will call defeat method, which will show defeat text and restart level after some delay. And the same we do in gold cup script, but we call victory method here. Now let's test our victory and defeat animations. As you can see, everything works fine. After collecting gold cup, victory text shows up and after some time level restarts. Same with defeat text. Now let's move our gold cup to the last room on the level and delete this unnecessary skeleton, since we already tested all we wanted. Although our game is tiny, I want it to be complete, so let's add some additional controls. Open player script and make a few adjustments. Those controls should work all the time, so we don't need to check if player is alive here. Let's restart the level on R key press. It may come in handy if player got stuck, for example if he destroys all the pods and can't get into the next room. Also, let's add application quit command on pressing escape button, so game quits. Test our adjustments in editor. Restart works perfectly and escape will not work in the editor, we can check it out later in the standalone build. Let's set some hint for controls on the screen so player knows how to play the game. Copy one of the text and paste it on the scene. Rename it to tutorial text, unhide it, set color to white and move it on the wall. Let's change text. Use WASD to move, use mouse to cast spells and press R to restart level. Also change anchor and alignment so it looks better and make it smaller. Now change alpha on the color, for example to about 10%, so it was visible but not too bright. Save it to Prefabs just in case as always. And that's it, our game is ready! Now let's make a build for Windows, for example. Unity is creating this window with graphics settings by default, you can disable it later if you want. And our game is working full screen, yay! Now we can finally play and show our game to friends and potential players, collect feedback and make game better. Don't forget to test your game a lot. Let's complete this level by getting gold cup, just to be sure that everything works fine. We can also make other builds, for example WebGL build works fine too, you can try it yourself, link in the description. Mobile builds will need some adjustments with controls because there's no keyboard, but mostly everything should work fine. Even with so small amount of features and mechanics, our game still looks complete, interesting and even challenging a bit. It's a good start. Later you can continue improving the game by adding more levels, features and stuff. Alright, we finally won, now we can test escape button and quit the game. As you can see, Windows build works like a charm. I tried to make this game very simple, so tutorial wasn't too hard, but there's a big potential here. You can improve a lot of things and add cool features, and here's some of them. Of course, there should be more levels than just one. Make more levels or generate levels procedurally like in roguelikes. Don't show all items and features in the first level, show them one by one. Keep player interested and teach him how to play gradually. Instead of gold cup, you could use ladder that leads to the next level. You can add more health to player so he doesn't die from the first hit. Maybe add loot and collecting mechanics so player has to pick up gold or something. Maybe gold coins will drop from destroyed pods and skeletons, maybe they will just lie on the floor. Add some bonus pickups like health potions which will restore player hearts. If you have gold in your game, you need some place where you can spend it. Add shop on some levels in which you could buy some items, for example permanent max health upgrade or health potions. Add some secret rooms with hidden treasure. For example, you can make destructible wall, which will reveal room after it's destroyed. Or you can make a hidden door, which is triggered by pressure plate. You can add traps, for example dart or arrow traps, which will shoot every time you step on pressure plate. Add more enemy types and bosses. For example, add red wizard in the last room. Maybe he will cast spells in you and summon skeletons. Add some animations. For example, blinking eyes animation on player wizard. It will make scene more dynamic. And of course you should add sounds to the game. You can even record your own sounds, sometimes they are the best. That's it for this video. I hope this helps you to make your first game or at least to learn some new tricks. If you enjoyed this tutorial, please share it with your friends and give it a like and subscribe to my channel. I put a lot of effort in this tutorial, so if you want me to make more videos like this, please let me know. Also, if you made game using this tutorial, share your results in the comments. By the way, I also work on my own indie game and make a video devlog about it. You can see it on my channel. If you like what I'm doing and want to support me somehow, you can check out my Patreon page, link in the description. See ya!